Resources Engineering and has been with the City of Welland since 2005. From 2005 to 2010, Marvin held the position of Construction Services Supervisor and now currently holds the position of Technical Analyst, Infrastructure Programs. Prior to his joining the City of Welland, Marvin spent 11 years in the consulting engineering field, involved primarily with the design and construction of municipal drainage, capital, and private development projects. Thank you for joining us, Marvin.
Good, thank you, and I want to thank ICLR for inviting me here. I'm not sure if being the last speaker is good or bad, so I guess I'm standing between you and getting out of here past the panel. What I wanted to talk to you about today was we were fortunate enough, the City of Welland was chosen to, I guess, host the climate change vulnerability study, and that's the purpose of my presentation today. The overview of the presentation, I'm going to start with acknowledgements of my project partners that we were fortunate enough to team up with. A summary of our study objectives and purpose, a review of the study area, an explanation of the PIBC protocol that was used, and I'll explain that a little bit later. A review of the City of Welland storm and wastewater combined system. That was the focus of the study. The climate variables that were considered. Kind of an add-on feature of this project was we really started the project by looking at updating our IDF curve. We currently use a very old 1963 IDF curve, and it kind of ballooned into a climate change vulnerability assessment, which was excellent. But the IDF update is a portion of this, which I'll talk about. There's a risk assessment component, and then I'll finish off with kind of what we're doing with the information in the next steps. I have a slide up here showing a lot of different partners. I wanted to key in on a few, and I'll highlight first of all actually the author of the report, AMEC. They were the consultant that we had prepare the information and the final report. So we spent a lot of time back and forth working with them, and I would say they were an excellent team partner. Ministry of the Environment, Water Smart Niagara, and Engineers Canada. Project funding was $120,000 project. Engineers Canada, you can see the split 40-30, and Water Smart Niagara was $50,000. And then there was in-kind from the city staff. Okay, study objectives. Engineers Canada, they're assessing the vulnerability issues and adaptation approaches for Canadian infrastructure in four key categories: buildings, roads, stormwater, wastewater systems, and water resources. It was actually the Welland storm and wastewater system that was selected, and I will say I thought Welland was special. I guess we are special, but we're not unique. There is a lot of combined systems all over, which I heard more of today, which is excellent because it's a good opportunity to kind of exchange and trade off information. The other objective, as I mentioned, was the IDF curve update and the need to consider climate change when constructing new infrastructure. That was really kind of what we wanted to take away from this project. Just to give you an idea of, if you don't know where Welland is, if you're from Winnipeg, Welland is, I'd say, central part of the Niagara region. On the left, you'll see a map showing where we are between the two lakes. And we do get some unique climate issues, I guess I'll call them, because of the two lakes. It makes it interesting. And then the other one is a blow-up of the actual city limits. The other thing I'll mention is Welland is a two-tier system. So the region of Niagara actually operates the plants, and then the City of Welland is responsible for the collection. That makes things a little more interesting as well, as any two-tiered municipality will appreciate. Okay, the privacy protocol. Privacy protocol is a national protocol developed through Engineers Canada. And what does it stand for? Public Infrastructure Engineering Vulnerability Committee. And it was formed to develop a protocol to, as I mentioned, assess Canadian infrastructure risk to climate change. The first protocol was established in 2005. There was a version 9, which was used in this study. Version 10, I believe, is the current version, and that's what's out there now. There's five main steps to the protocol. Infrastructure of interest. Do we have data? And there is lots of data out there, but it's interesting when you go through the process where you do see the lapse in the data, or the gaps. Loads and impacts, more analysis required, so you need to do some further studies, and then at the end, what are the recommendations that come out of it. So step 1 is the project definition. Involves the details of the infrastructure, site setting, and a climate overview. Step 2 is the data gathering. City of Welland has a fairly good database of their information, particularly with our linear assets, not so much necessarily for some of the other assets, but we're in pretty good shape with our storm and wastewater and combined systems. So step 2, there's a certain amount of judgment, obviously, that has to go into it. And you can see judgment on significance, the likelihood of something happening, response, uncertainty, and then the last part of step 2 was the IDF analysis. Step 3 was the risk assessment. Once again, a significant amount of judgment involved judgment of significance, the likelihood, judgment on response, what will happen in a certain climate change event, more rain, more snow, ice events, that sort of thing. Judgment on uncertainty. We don't know what's going to happen, so there's a lot of what ifs. And there was an assessment workshop, which I'll get into a little bit more in a few minutes. Step 4 was the engineering analysis. Do the existing infrastructure, well, I guess the question is, does the existing infrastructure have enough reserve capacity? So, and I'll talk a little bit more about that later, but we've talked about how much can a system accommodate? Where is it right now in the process of transferring from A to B? And if climate does change, there's more of this, more rain, more snow events that eventually melt, that sort of thing. Does it have the capacity to handle that? And it's looking at that reserve capacity. And then the step 5, which is the final step, there's really 4 main categories of recommendations: remedial action, management action, no action, and then the additional study required. And there's a little table later on. I'll go into that a little bit more. The next 2 slides is a summary of specific to the Welland's wastewater, combined, and storm system. And I don't expect you to see this in detail, but it's just to give you an idea that on the blue is the storm system, and on the right is the sanitary system. We've just highlighted those in different colors. There's a couple graphs here, and I won't go through all the lines and bar charts in detail. I'll just highlight a few things. Like a lot of old municipalities, there's a lot of pipe in the 40 to 60-year-old range. A lot of infrastructure, as you know, was built right after World War II, so 1950-ish era, and that's all obviously getting older and coming to a point where it needs some attention. And obviously the combined sewers are the oldest. The bar chart on the right, you'll see what we do is we rate our system right now. It's a letter grade, A being the best, and obviously F the worst. There's a lot or actually half of the combined system is in the sea or worse. So there's a lot of pipe that needs some attention. This is just a table of kind of a breakdown of the City of Welland's network, storm and sanitary. I won't go through all the numbers, but I'll just highlight a few. The fact the total length, storm 186 kilometers and sanitary combined 268 kilometers. City of Welland's population about 50,000. So I always say it's a kind of a small municipality with kind of big city type problems, but small budget. The I think maximum size, we have some pretty large stuff even for a smaller municipality. You can see the size of the storm, 3-meter diameter, 2.7 sanitary. So there's some pretty big trunk sewers. And we have some old stuff, like I'm sure a lot of you do as well, 100-year plus. So I'm going to talk a little bit about the climate variables that were looked at as part of the study. Here's a list of them here, and I won't go through all of them again. I'll highlight a few. Temperature, obviously, rainfall, snow accumulation, winds. There's actually a lot of variables that were incorporated into the project that you stop and think, like, why are we even looking at that? But it's interesting. Even an ice storm, well, it could impact getting fuel to the treatment plant backup system, something like that. So it was stuff that I hadn't really thought of before that it was kind of interesting as it came out in that study. This is just a kind of a timeline chart of the data that was available for our study. And I mentioned the 1963 IDF curve. And then as you move over to the right, there was information, data available, kind of that long pink graph between 1965 to 2005, something like that. There's a 2000 IDF curve that was available. That was from Port Colborne, which is to the south on Lake Erie. And then the 2020 and the 2050 that's up there, that was really the projected IDF curves based on climate models. I'll talk about that in a minute. Here's what we project will be happening in 2020, and let's move that even forward to 2050. The purpose of this slide is really just to show some temperature trends. The yellow line on that line graph, it's graphing, it's a timeline along the bottom. And it refers to June, July, and August, so that's why it's at the top. And the temperature you can see over that extended period of time between 1970 and 2009 has an average increase of about 1.4% or 1.4 degrees Celsius. And then the chart kind of on the bottom right, on the far left column, the greater than 30 degrees Celsius. Historically, 7 days per year, and that's based on data that was available. Projecting into the future, 9 days, and 2050, 17. So I'm sure pool sales will climb over the next few years. But interesting, 35 degrees, there really wasn't a significant increase. But there again, this is based on predictions and models. Okay, some of the general outcomes that came out of this review, and I'll go through them quickly. Privacy protocol premise was based on 2 future timeframes, as I mentioned, 2020 and 2050. The number of days per year with temperature exceeding 35 degrees Celsius is anticipated to remain the same, but through 2020, 4 times. Remain the same in 2020, but up 4 times. In 2050. The number of days per year with temperature below -20 to decline, so maybe that's a good thing. Occurrence of heat waves to hold through 2020 with slight increase through 2050. Days per year of free thaw cycles to decline. Rainfall and severity of rain events expected to increase. So really, it showed that there would be a slight actual increase in the total volume of rain, but what was really noticeable was, and we've all seen it, the rain's going to come at higher intensity, it's going to come quicker. And then the occurrence of dry periods, drought, to double through 2020. Okay, the next few slides refer to the IDF portion of our project. As you know, the IDF curves are used to do storm sewer sizing. The City of Welland currently uses a 2-year design storm using a 1963 curve. So you look at that and I think you would suggest that maybe we are a little bit out of date, and that's something we are working on. The original 1963 curve was based actually from the Buffalo weather data. And going back to the map where Welland is, Buffalo is actually on the east end of Lake Erie. And although we do get similar weather to Buffalo, it isn't exactly quite the same. We actually get a little bit more precipitation. Particularly winter events are a little more interesting in Buffalo. The new curves are based on Environment Canada data from Port Colborne, which was to the south on Lake Erie, and that was based on the year 2000. This is the current curve that the City of Welland uses, 1963. And this is the Port Colborne 2000 curve. So to generate the new IDF curve, the consultant he had to consider a bunch of things. There was 40 years of data available, which is good. Actually, more is better, but that was what was available. What I found very interesting was all the different climate models actually that were run. I never obviously ran them or had to deal with them, but basically they ran all these 112 models and then looked at all the results, and then you could see a trend from the results. And that's what was used to predict what would happen in 2020 and 2050 in terms of the IDF curves. Something interesting that came out of this analysis was that the 1963 Buffalo curve that we use is actually fairly conservative. So there was more work required, which I'll mention in a minute. But really, at the end of the day, what was decided is we should continue for now using the 1963 curve before the more frequent storms. It was actually a conservative curve to use. But the question really is still what curve should be used, and we do have to do some further analysis, and actually EMEC is helping us with that. Okay, the purpose of this slide is simply to demonstrate that there's a certain amount of uncertainty. There's, you're running all these models and you're getting output, but it's really predicting what's going to happen in 2020. And if anybody has an answer to that, then that's great. But you do have to base it on something, and then it is a prediction, and there is uncertainty with it. The global climate models, obviously there's uncertainty with those. Top 10% of the projections show actually a large increase in precipitation, which the final output from the report was no, there wouldn't be a large increase. Most of the models showed a slight increase, but the rain would come, as I mentioned, quicker. And kind of the second to last bullet, use your judgment, and that's something you have to really look at the output and see if it makes sense. This third step in the PIVC process was the risk assessment, and what that part involved was it was really a workshop. It was a room maybe half this size, but we brought in engineers, climate specialists, operations personnel, resource managers. We had conservation authority staff, university professors, kind of brought them all into a room, and basically what we did is had a bunch of questions that were asked and created or filled in a matrix, basically a risk matrix. and that's an example of actually what was in the report. It was really based on professional judgment and experience, and it was actually a very interesting process to go through and kind of pick everybody's brain that had been through the process. The only thing I want to highlight on this slide is that I talked about it before, it's really, vulnerability exists when the total load is greater than the total capacity, and obviously adaptive capacity exists when the total load is less than the total capacity. So it's simple, it's just whether or not you can determine what that will be in the future. Okay, the recommendations that came out of the report, there was 4 main categories: remedial engineering, management actions, additional study, or no further action required. This is a slide showing a summary of the recommendations that came out of the report. There were 44 of them. I'll just highlight a couple of things. 33 of them were less than 100,000, so not real expensive stuff. And 12 of them were the ASAP or due now. The short was a 1 to 5 year time frame, medium 10-year time frame. So really what Welland's doing is we're looking at the kind of ASAP, low-cost items, get that low-hanging fruit that we can move forward with and kind of start the ball rolling. This is just simply a slide as an example of the recommendations, how they were grouped, and we have a report actually on our website that has all this information. But this is really kind of a reference report now that we're going back to. Primarily when we do capital budgeting, we'll look at what information was recommended and which ones we can move forward. A couple of ASAP recommendations which we're working on kind of as we speak is evaluating the Idf curve, whether the 1963 one is the one we should be using, or should we be looking at using the Port Colborne 2000, the 2020 or 2050 projection. And that's something there, again, I mentioned EMAC is helping us with, in addition to number 2, which is whether we should be upgrading our design standards to a 5 or even a 10-year design standard. Next steps, the final study, as I mentioned, is on the city website. Engineers Canada has added the study to their database. The MOE has profiled the study in their annual climate ready report. WaterSmart has included within their report that they just published. It's not annual, but it's included in there. And then, as I mentioned, the City of Welland is moving forward with a few of the ASAP recommendations due now. The IDF curve analysis, design storm analysis, and the last bullet there is we're moving forward. We don't expect to have it complete probably till next year, but a citywide sanitary sewer model. And coming from that is a pollution control plan update to kind of guide us to complete our sewer separation work. This is some contact information, myself and the co-authors of the report, Ron, who I saw here earlier, and Peter from AMEC. And that's all I have. I think I'm out of time too. So. Thank you.
Thank you, Marvin. Do we have any questions for Marvin?
Marvin, can you talk a little bit about the different types of works, like in terms of those recommendations? You mentioned that most of them are fairly inexpensive. Can you elaborate a little bit more on what the recommendations were in terms of actual work on the ground?
Yeah, as I mentioned, the recommendations were grouped into different categories. Some were as simple as, how do I put it, to collaborate a little bit better with the upper tier. Sometimes there's the upper-lower conflict on who does what, that sort of thing. So it may be something simple as having regular meetings, getting on the same page. And actually we've been moving forward with some of that, and that really is a low cost. It could be something as simple as doing an annual meeting on sewer flow monitoring. instead of the region doing theirs and the city doing theirs, kind of gathering the information and combining it. So something simple as that. The last, actually 3 bullets were some 3 key recommendations that we're moving forward with. The IDF curve, which I think taking a better look at that will help us as we move forward, not only with our own capital works, but with future development. That ties in obviously with our design storm standard. We've been using a 2-year design storm forever, I guess, and I think that's, as we all know, I think that's outdated as the storms increase. And then our pollution control plan update and citywide sanitary sewer model. I think that really is key. We really did push that one. It's not cheap, and it's very time consuming, but I think having that model will really help us finish off our sewer separation work and really direct I guess our capital budgeting on almost for the next probably 8 to 10 years. So I don't know if that answers your question.
There's Larry Thompson. You commented that in the end you discovered your 1963 curves were a little bit conservative. Would that indicate that your 2-year design storm that you thought you were designing for, actually when compared to your newer or Colburn one, is something greater than a 2-year?
Yeah, I think what it told us was that, for example, if we were to use the projected 2020 curve, or even the existing 2000 Port Colborne curve, and the 1963 curve to design, to do the same design, we'd actually be, I guess, more conservative using the 1963, or it would be a safer design using the 1963.
So it's more equivalent to, say, a 5-year storm or something in between that, with your newer data?
Yeah, depending on there again the curve. If you looked at, yeah.
Thank you for your questions. And Marvin, thank you again for your excellent presentation. So Marvin will be on our panel, so I invite you to, if you do have any more questions for him, that would be a good time to, bring some discussion out there. Without further ado, I think we'd like to bring our 6-person panel forward, and we're on schedule, so that's good. 4 of the panel members have spoken today. They are Marvin, who is just up here from the city of Welland, Murray Pound from Gold Seal Homes, Christine Zimmer from Credit Valley Conservation, and Mario Senego from City of Windsor. 2 additional members of our panel haven't spoken yet. They are Chris Smith from Region of Peel and David Kellershone from Toronto Water. And I will give them, briefly introduce them as you come forward and sit down on our panel. So I invite you to come